Hello, welcome to another video by LSX Engine Tuning and Marine. This video is the first in a series of installing pistons in a Mercruiser 4.3 liter V6. And so what you see now is a 4.3 liter block on the engine stand. This is turned up to where cylinder number 1 is pointing up, number 3, number 5. I'm going to demo number 1 first. So the first step in installing piston rings, after you've assured that your piston to wall clearance is satisfactory, which I did in previous videos, is to you have to gap your rings. So what I've done is I bought a set of Seal Power, these are Federal Mogul E-251K 30 rings. That means 30,000 oversized E251K. Now, if you watch some of my previous videos or the first video in this rebuild series, you would have seen that this is a set of V8 rings. But the V8 and the V6 or pistons are the same piston. So you can buy a set of V8 rings for cheaper than a set of V6 rings and have 2 sets left over. That way if you mess up a set of rings, you have 2 spares. Or you can save 2 for every 3 sets you buy, you get 1 extra V6 motor out of it. But anyway, so I'm about to unbox these rings, and what I'm going to do is push them down in the bore. All these bores have been checked, and they're exactly 30,000 of an inch oversized top to bottom. I mean, they're right on the money. There's no taper. They're perfectly round. They've been checked, so they're exactly 30,000 oversized. So what I'm going to do is insert the rings one at a time. You do your top ring, your second ring, and then you can check your oil control rings if you want to, but they're usually so wide they don't matter. But so the factory recommendation, what I'm using for my specifications is the Kohler 4.3 liter industrial service manual. And since it's an industrial engine, it's running hard, so that's the specifications I'm using. And the top ring gap, max gap, is 0.016 inches. And according to Clevite and other sources I've read on the internet, you're supposed to increase your ring gap by 40% for high RPM or high performance engines. So 0.016 increased by 40% times 1.4 is approximately 0.022, 22 thousandths of an inch. So I'm going to set my top ring at 22 thousandths of an inch. And then the maximum on the Kohler service guide, the maximum for the second ring is 0.031 for your top of your range, for your max range on a service for your normal range for your ring. So you're supposed to have a slightly larger second ring gap than your first ring gap. It's to prevent something called ring flutter. I'm not really sure. I did a little research on it, but I don't know all the details. So if you're more interested, you can Google that and find out what it's about. But the bottom line is your second ring gap is supposed to be a little bit bigger than your first ring gap. So 0.022 is going to be my first ring gap, and 0.031 is going to be my second ring gap. Continuing with the piston ring installation, as you can see, this is the top. Well, you can see the top ring, about ready to put it down in the bore. And so what I do, you leave the open end like that, and you just push it down a little bit, just a smidgen in there. You twist it down to where you can get it in the hole, like so. Then to get it evenly down the hole, you take another piston. This is a 4-inch, 30 over 4-inch piston, and I've got 1 ring on it already, the lower ring, the second ring. And so I use that to push the other ring down an equal amount. So let me see, get this in here. There you go. So now the ring I just pushed in there, or placed in there, is pushed down the same amount all the way around, because the ring on this piston stops it. So now it's placed in there. So at this time, you then take a feeler gauge. I'll do all this with one hand. So you take a feeler gauge and you check your gap. I've got the feeler gauge set on, I don't know if you can read that, 0.022. And you check your gap and see if it goes in there. So I'm getting some light in there. It's kind of hard to do without. Try to see what I'm doing and do the gap too. But you get the picture. I'm gonna have to put this camera down and do this with 2 hands, but I'm putting the feeler gauge in the gap. If it doesn't fit, you have to take the ring out and file it to where it does fit. So I'm gonna go ahead and check this ring and off camera, and then I'll show you the results when I'm done. All right, continuing with the piston ring install, the last check with the feeler gauge, the gap was too narrow. So I pulled the ring back out and I filed on it with a file. And the gap obviously opens up. Let me show you another ring. The gap opens up about that far, so you can get a file in between there. And I'll file on one side, just my preference. I just file on one side only until I get the gap right. And now I've got a 22 feeler gauge, and you can see that the 22 feeler gauge fits in the gap now. And it's a little bit loose, so I filed a little bit more than the 0.022, but that's okay. I just want to get it close, or within a thousandth or two. So I think it's try it one more time. Try to keep my hand out of the way. Yeah, you see how it goes through there? It goes right through there. So that gap is set. So now I'm going to repeat this process for all 6 top rings. Then I'll do the same thing for all 6 the second ring, but I'll change the gap to 0.031 on my feeler gauge. And as long as it's that big or close to that, that's acceptable. So I'm going to go ahead and finish up gapping up 12 rings now, and then I'll show you what I do with the oil control rings when I'm done. So I'm going to do all 12 rings at this time. Alright, continuing with the gapping of rings. I've now gapped all 12 rings, the 6 top compression ring and the 6 second groove ring. And I'm now showing how to gap the oil control ring. The oil control ring, per the Kohler 4.3 industrial manual, states that the service range or the production range for this gap is 0.010 to 0.029. And since on my second groove ring I'd settle on 0.028, I went 0.022 times 1.25 to get 0.028. So I set my second ring gap for 0.028. I read somewhere that you set your second ring gap 25% bigger than your top ring for to avoid ring flutter. So anyway, this is the oil control ring, and it has a wide gap, and it doesn't really, you don't have to expand it for heavy duty use because it's a very thin ring, and it will, if it were to butt, it would bend a little bit. But so anyway, I left the gap at 0.028 on my feeler gauge, and all of them checked out without having to file or anything. So they're all over 0.028, so they're all checked out good. So all the oil control rings are now done, and in the time between the last video and the one I'm doing now, while my camera was charging, I had the opportunity, or I had the time, to go ahead and put all the rings on the pistons. So what I did, I use this is a piston ring expander tool, and it grabs the butt ends of the ring, expands them out, and you put them on the piston. And there's not really a whole lot to say about that. You just have to work it on there. You work it, figure it out yourself, work the piston rings on. So this is my number 1 piston. I've got all my pistons already numbered in the hole to go in because the rods go in a certain way. And so you can see I've got the top ring in, the second ring in, and then the oil control rings in. And I've done this on all 6 pistons. So the next step is to install these pistons, and I'll do that tomorrow because I'm calling them tonight. But that's how you install piston ring. You gap your rings, install your rings on your pistons, and then you put them in the cylinder bore. And I'll discuss the ring. You orient the rings a certain way when you put it in the bore. So I'll discuss that when I actually put the piston in the bore. That's the end of this video, and pistons are ready to be installed. So thanks for watching.